Hello everyone, welcome back to Analytical Guy. In this video, we will continue our Microsoft Fabric playlist. Till now, we have talked about introduction to Microsoft Fabric, where we talked about the interface part, how many experiences do we have, how to configure and how to play around with all these experiences. So that was video number 1. In video number 2, we talked about the concept called Lakehouse and how to get started with Lakehouse. So we discussed the concept and then we tried to create our first Lakehouse in Microsoft Fabric. So that was video number 2. In this particular video, this is Apache Spark, and Apache Spark is a powerful tool for big data processing. So if you're working with large data sets and need to analyze them quickly, then Apache Spark is for you. So in this module, we'll talk about the concept, the architecture of Apache Spark, then we will configure Spark in Microsoft Fabric Workspace. Then we will also identify suitable scenarios for Spark notebooks as well as Spark jobs. And finally, we will talk about using the Spark data frames and how to use Spark SQL to query data in those tables. So this is what is expected from this particular video. In upcoming sessions, we will talk about how to work with the delta tables, delta lake tables, and how to create the pipelines in Data Factory and much more. So let's continue with our module number 3. So first of all, the definition of Apache Spark. What is Apache Spark? So it is a core technology for large scale data analytics. So Microsoft Fabric provides support for Spark clusters, enabling you to analyze and process data in Lakehouse at scale. So if you're new to Apache Spark, so let me tell you, Apache Spark is nothing new. So it started in early 2000s started with Hadoop. I'll explain you the timeline as well. So this is nothing new, nothing which was invented by Microsoft Fabric, nothing as such, right? So this is the concept which was already there and Fabric incorporated in their platform. So it is an open source framework for large scale data processing and analytics. Also, the clusters of Fabric Spark provides a powerful in-memory distributed framework for at-scale data processing. So whatever you're seeing 3 definitions here, that will prove you that Apache Spark is meant for large data, that is big data that we call, right? So if we talk about one more definition, Apache Spark is an open source distributed computing system. So think of it as a super fast engine that helps you process massive amounts of data across many computers at once. So it's not like just one computer is working at one point of time. It will be multiple computers. So you can distribute your tasks and all the individual machines can work on it. And then finally the outcome can be collaborated. Right, so this is what the Spark does. So why Spark? What makes Spark special is its speed and simplicity. These are the 2 main things for Spark. So if we see here, Spark can run code written in the wide range of languages. So it can be done in Java, Scala, Spark R, Spark SQL, PySpark. So for me, it will be Spark SQL and PySpark. So I'm more familiar with SQL and Python. So this resonates with me more, and you have a dedicated notebook in Microsoft Fabric. You can utilize these languages in your to build frameworks. So now let's talk about the timeline. So it all started with Apache Hadoop. That was 2004. Inspired by Google, Hadoop became so popular for big data, and that was 2004. After that, there was an adoption from Yahoo in 2005. So Hadoop was adopted by Yahoo for its big data processing. And then in 2008, first stable version of Hadoop was released, including HDFS and MapReduce. So HDFS is Hadoop Distributed File System, and MapReduce, that is a computing system of Hadoop, enabling distributed storage and processing of large data sets, right? And during 2009 and 2013, that 3-4 years, that was a time when Apache Spark was developed, and it was developed at UC Berkeley's AMP lab, as a faster in-memory alternative to Hadoop's MapReduce. So MapReduce is comparatively slower, so that's why Apache Spark replaced it in terms of speed, and the goal was to address high latency of disk-based processing in Hadoop. Right, so if we say Apache Hadoop is not equivalent to Apache Spark, so these two are, you can't say that Apache Spark will replace Hadoop. You can say that Apache Spark will replace MapReduce, right? So it was during 2014 that Apache Spark was released as a stable version, and it gained popularity because there was a support of in-memory processing, Spark SQL ML library for machine learning, and Spark streaming for real-time data. So it was there, and that's why it became popular. It was 2004, and then in 2005, somewhere around 2015-16, Spark began to replace Hadoop's MapReduce as a preferred big data processing engine. So this is an engine, MapReduce and Apache Spark. So Apache Spark is faster, and it provides high latency, so it replaced MapReduce, right? So now if we have to compare Hadoop with whatever we have in Fabric, so it can be on the base of storage, it can be based on computation and resource manager. So storage, Hadoop uses SDFS, that is Hadoop distributed file storage. In Fabric, it is OneLake. So OneLake is the place where everything is stored in Microsoft Fabric, right? For computation, that is MapReduce. In Fabric, we use Apache Spark. Resource manager, it is Yarn for Hadoop, and there is internal resource manager for Microsoft Fabric. So Apache Spark is an alternative to MapReduce. So we have already discussed, so these are the languages that can be used inside the Apache Spark. Now let's discuss about the architecture and the Spark pools. Spark pool consists of compute nodes that distribute data processing tasks. So if we see here, there will be multiple monitors, or you can say multiple machines, which will do their own individual task, and output will be the combination, or you can say summarization of the outcomes that are there from individual machines, right? So let's say you have task A. It can be divided into task A1, A2, A3, A4. So let's say you use 4 machines for that. One machine for A1, second machine for A2, third machine for A3, fourth machine for A4. So now you have 4 machines doing these tasks individually. And let's say each of the task is completed in, let's say, 10 seconds, 15 seconds, 20 seconds, and 25 seconds. So overall, so once this is done, you will combine the output, and your task is completed in 25 seconds. That is maximum. Otherwise, it would have taken you 15 plus 20 plus 25 plus 10, whatever was the time, right? So it is immensely reducing the time to compute the process. And this is what the architecture looks like. So if we see, these are the main components of Apache: Spark SQL, then Spark streaming. This is for live data. Machine learning for all the algorithms you want to do, like for supervised or unsupervised. Then we have GraphX. So this is Spark core engine. This is important. This is used to get the data flowing in the system, right? And it works on driver worker module, where we have a driver program which has Spark context, and this is where from the data is flown to worker nodes, which works as individual monitors which do individual tasks. And this is all managed by a cluster manager, because you have to manage the input, output, what time it's flowing in, what time it's flowing out. So this is all managed by a cluster manager. So as shown in the diagram, a Spark pool contains 2 kinds of node: a head node and the worker node. So head node in the Spark pool coordinates distributed processes through driver program, as we discussed here as well. There is a driver program, and pool includes multiple worker nodes on which executor processes perform actual data processing task. This is my worker node. So let's discuss what we have already discussed so far, and then we will go to Microsoft Fabric to create our own first version of Apache Spark. So Spark is a processing engine. It is an open source framework. In Microsoft Fabric, it uses OneLake as for the storage, internal resource management system for resource manager. So let's compare MapReduce compute with versus Apache Spark compute. So first feature would be data processing. So data processing, it is a disk based processing with map and reduce phases. So this was a challenge. That's why Spark came into the picture. In Spark, it is in memory processing for most operations, reducing disk input output. Speed and performance. So map reduce compute is slower due to RISC writes after each step. For Spark compute, it is fast because it is in memory. Ease of use. MapReduce requires extensive coding and uses Java or Python with complex boilerplate code. So if you are not a developer, you are less versed with the coding world, then MapReduce compute might be challenging. Whereas Spark compute is high level in terms of less coding and provides high level APIs in Scala, Python, Java, in R. So if in case you want to work on, let's say, Python, you have various APIs which you can connect to, and it has easier syntax for data processing. Finally, one more feature is real-time processing. It is not suitable. MapReduce doesn't provide anything for real-time or streaming data, whereas in Spark Compute we have a component which supports real-time processing through structured streaming. Alright, so this was it about the theory. Let's try to work on Microsoft Fabric. Alright guys, so now we will try to analyze the data using Apache Spark in Microsoft Fabric. In order to do that, first of all, we will create our workspace. And in order to work on Apache Spark, we generally use data engineering experience, right? So if you go to the bottom left icon, click on Power BI and just click on data engineering in Synapse, and this is how it will show. And then you can click on new workspace and you can name it, let's say, workspace, or I can say module 3 Apache Spark, right? And in advanced you can click on trial and click on apply. So this will give you the blank workspace, and in this workspace you can create a lakehouse. You can click on new item, click on lakehouse, and lakehouse can be, let's say, lakehouse for module 3. Alright, so if I write this, it will show me names can only include numbers, letters, and underscore. Definitely, so I should have like this, lakehouse underscore module 3, and click on create. Right, so our lakehouse is created. So if you want to understand in depth how it should be created and what are the do's and don'ts, you can watch the previous video on getting started with lakehouse tutorial. Right, so now we have created this lakehouse. Next step is to upload the files. So I have added the link of my GitHub where you can download this file. So it has if you go to this link, it is orders.zip. so you just need to click on download raw file, and it will have 3 files inside a zip folder, right? So now if I go back and click on files, click on upload, and click on upload folder, and I can remove this which is already there. I don't need that. So if I click on this folder and I click on downloads and orders 2, this is the folder I want to select. So it's saying upload 3 files to this site. This will upload all 3 files from orders to folder upload. So I can click on upload. So once this gets uploaded, which is done, I can close this, and you will see under files, you will see this folder orders, and it has these 3 CSV files. Alright, so now we are done with uploading the folder. Now the next step is to create the notebook. So I'll just click on open notebook and click on new notebook. Otherwise, what you can do is, if I go to workspace module 3 Apache Spark, here I already have Lakehouse, I have semantic model and SQL analytics endpoint. Now from here I can click on new item, I can click on notepad, notebook. So this is in favorites, otherwise you might not see in favorites. This is what I did. So you click on all items and search for notebook here. Otherwise you can search notebook and it will be there, right? So once you open the notebook, you can rename it. Let's say rename to module 3 in analysis with Apache and press enter. Alright, so Lakehouse, so it should be my existing Lakehouse. Click on add. So Lakehouse underscore module 3 is my Lakehouse in this particular module. Click on add. So I can see orders folder over here, right? Now what I can do is, if I just select 2019.csv and click on 3 dots, I can click on load data and click on Spark. So it will give me the line, Spark line, which will on execute give me the data frame. So here it is showing df is equal to spark.read format CSV. So it's saying the reading format, the format of the data is in CSV. And then I'm saying the option header is equal to true. That means it has the headers, and load 2019 file, right? And then once it is loaded, display the data frame. Let's run it and see what it does. So if you're new to notebook, so there are two things which you have to consider. One is the code and one is markdown. So in case you want to create headers, so that will be markdown, otherwise you have to select the code, right? For example, so if I select here, you will see there is a code option, there is a markdown option. So I can click on markdown and let's say this is analysis of data using Apache Spark and press enter, right? So this will give me the header, and I can make it two hashes or 3 hashes to make it smaller, right? So with the hashes it will change the size of the font of the text, right? So now this was the markdown. Now if I want to add a code, I click on plus code and then I can write a code. And then if I have to delete, I can remove this cell as well, right? So this is how the notebook work. I can delete this, it is not needed. So this got executed and I can see this table. So here I have multiple columns with like SO 473711. It is not making sense. Why? So there is one problem here. So when I said header is equal to true, so it omitted the header. So rather I would modify this and let's say header is equal to false, and let's see what happens. So in this case I should get the headers back, right? So now you can see here my headers are back and it's saying C0, C1, C2, C3, right? So you can rename these headers, it's up to you, but right now we won't be doing that. So let's work on very important part, that is data types. So as you see over here, so you can see all the data types are ABC, right? Which is not correct. So my column 3, for example, this should be a date, this can be a integer, this is string, so ABC is fine for this. So we have to decide which is string, which is not. So let's try to create a code. So for this we will use struct type. So this is something which you have to work in PySpark. So in order to define the data types, we work on the schema. So we will create a schema, let's say from PySpark session. So we will create a session and then we will work on types. So I'll import PySpark.sql dot types. So this is where from my field structure types will come. Types, I'll import everything. So it will be asterisk sign, and then I'll say, let's say order schema for this is struct type, and then bracket, right? So this is my struct type, and in this I want to create a list of all those columns. So if I go here, my first column name is C0, right? So I'll just say struct field, it is underscore C0, right? I want this to be string type, so I'll say string type, right? So this is fine. Similarly, I'll go for second column, that is underscore C2 or C1, and it will be C1, and it should be integer type, right? So it is integer type, and then bracket closed again. All right, so now I can copy this to make my life easier. Right, so this should be C2, 3, 4, 5, 6 until C8, right? So it is 2, 3, 4, 5, and 3 more. 6, 7, 8, right? Now my first is string, then integer, then I have date type, then string. So string, integer, then I have date type, then I have string again, string, so this is string, then C5 is string again, item is also string, right? Then I have a quantity, this is my integer, and this can be float, looks like a price, and this is tax, again float, right? So this is my float type, this was again my float type, and this was integer type, and this is my string type, this is string. Oh, by mistake I wrote integral, so it should be integer, right? All right, so this is done, right? So now I have created this schema. Now I have to call this as in data frame, so it will be spark.read. So read this in the format of CSV. So I'll just say CSV dot schema of order schema dot load the files. So it will be in the files, it will be orders to 2019.csv, right? So if I run this, hopefully this data frame is created with the data types we expect, right? So it should be string, integer, date type, string, integer, float, rather than all being string type. All right, so this is created, right? So let's display it. All right, so let's see. This is ABC, that is string. This is 1, 2, 3, that is integer, date, string, integer, float. So this is amazing. This looks so much better, right? So this is making more sense versus this data where everything is ABC, that is string, right? So let's try to work on exploring the data in this particular data frame. So for that, let's say you want to uh, explore just two columns. So if you want to extract just two columns, let's say that is my underscore C3 and underscore C4. So how you can do that? So it will be, let's say, customer is equal to data frame. So df is my data frame over here, so it should be equal to this, right? Data frame, and I want underscore C3 and I want underscore C4, right? So this data frame will include just C3 and C4, and now I'm saying print this, print my customers dot count. So this will count the number of values in these columns. So that's 1 to 0 1. Now I also want to count distinct values. So if I'll say print on customers, so I'll use one function that is distinct dot count as always. And now instead of 1 to 2 1, sorry, instead of 1 to 0 1, again it is 1 to 0 1. So that means every value is already distinct in C3 and C4. So now if I say just distinct and not count, so what will it give me? So it gives me data frame underscore C3 is a string, underscore C4 is a string. All right. So this is how you can use PySpark. So instead of PySpark, you can use SQL Spark as well. So if I just do it markdown to make it beautiful, let's say explore data using PySpark. All right, so I'll just write explore more. All right, so now I'll remove this. I'll have a code. Now you will have more code depending on what you want. So let's say I want C3 and C4 where my item is, let's say, road 150 red 52. All right, so what I'll do is I'll just say, let's say it is customers equal to, so df is my data frame, so df dot, and I want to select two columns, right? So I'll just use df dot select, and now I'll say underscore C3 comma then underscore C4, right? So I have selected these two columns dot. So till now I have selected two columns, but it should be selected on the basis of one condition where the data frames column C5, that is my item, right? So whenever this item is equal to my road 250, and what was it? Okay, so it was road 150 red 52, road 150 red comma 52, right? So this is the logic. Now let's say if I want to print this, if I want to print customers, for example, what will happen? So again, customers will give me that C3 string, C4 is string, because that's again we don't want that. Let's try to count. So now it is 155. Initially it was 1201. So 1201 is total where I am having the count of customers, but there are 155 customers where the item is equal to road 150, red 52. Again, now if I print customers dot distinct dot count, so what will be the output? Again 155, because for this combination my distinct will be the same as we saw over here. All right, so this is how we are using PySpark to explore the data, and then we can use various other functionality like we do in SQL also. So for example, if you want to group by a particular column, you can do that as well. For example, let's say markdown use group by function, right? So now here I'll write, let's say I want to see product sales, so it will be product sales equal to df dot select. I want to select my item, so item is underscore c5, and quantity, let's see quantity, this is my c6, right? So I want to select item as well as quantity, and I want to group this on the basis of item. Item is underscore c5, and then submit. So if I display this product sales, what will happen? See, so if you see over here, it is grouping on the basis of c5, so all the individual items, and it is summing my count of on the base of c5 and c6. So this is my total sales. So mountain 100, silver 42, total quantity sold is 21. So this is summing c6, right? Road 650, red 52 is number 10. I can also sort this. I can add the descending factor like sort, so it will sort on the base of total number of quantity, and then you can analyze which is the highest product sales, right? So this is about the PySpark and how you can analyze the data, and we can also use the SQL part of it to work on it, and we will work on one more part. So till now we have worked on the analyzing part, so we manipulated the data and created the data over here. So now we will try to transform. By transform means if I want to create a new column through the existing column, so I'll say transform data. So here in transforming I have to use something called SQL functions in PySpark that will have all the functionality which I want. So I'll say from PySpark .sql.functions import everything, and now I want to have a transformed data frame. So it will be equal to data frame, which is our original. I'll say with column. So this is another function. So you have to work on the basics and the syntax to understand how to use. So what I'll do is I'll create a year column. So we already have this column order date, right? This one, third column, that is underscore c2. So this is my order date. Through this I want to extract year, so it should be 2019, and wherever it is 2020 it should go there, right? So I want to extract that. So with this column I will say the new column is year, and I want to extract year from the column name is underscore c2, right? So from c2 I want to extract the year, and that will be the year. Also I want to extract month. But let's say let's work on this, just the year part. So if I display this, I'll copy this and go in display. Let's see what happens. So if we see, we already have C0, 1, 2, 3, 4, 5, 6, 7, 8, and now a new column has been created, year, which is giving me 2019. So maybe there is only data for 2019. Yes, it is only for 2019 right now because we extracted just 2019, right? So now we have transformed this, but I want to add another column, that is month. So with this, with columns, so with column, I want to have month column as new and extract using month on column, and the column name is underscore C2, and then press run. So if we see here, it is giving me month as well. So it is giving me 7, 9, 10. So these are all months, right? One more analysis. Let's try to transform one more thing. Let's say I want to create let's go back to the data set and see what we can create. All right, so we have this name, right? Kelly Sands, Derek Goel, Rosalu, Natasha Gutierrez. So we have first name as well as last name. So let's try to extract first name in one column, last name in another, right? So we have to split this column, right? That is underscore C3. So let's try to split to extract first name and last name. All right, so now for this we will again say transformed df is equal to transformed data frame, which is already existed. With this we'll add a new column and the name will be first name, right? And then I'll say split my data in the column underscore C3 in the double quotes, right? So in C3 I want to split this and then say blank, right? And now get item, I want to get the first element, so it will be 0 because indexing starts from 0, right? Dot. So once you are able to do this, now you want to extract the last item. So 0 has the first name, right? So if you go here, so if you see this name Claudia Sun, so this is my Claudia is the element 0, so that is my first name. So that's why C3 blank and then get name 0, right? It's better to have space over here. And oops, so I missed a comma, I guess, over here. Yeah, so the second element should be the last name. So I'll say with column I'll have last name, and in last name we'll split again on the column customer name, so that's underscore C3. So once this is there, we will again give the blank and dot get item equal and bracket 1. So that is the first, like second item, so that will be 1, right? So let's try to run this. Hopefully it will run without any problem. Yes. So if I display this and run this, we'll see what happens. All right, so if we see over here at the end, we have first name as well as last name. First name is Christy, last name is Zoo. First name here is Julio, Ruiz, Curtis, Lu. So we have first name as well as last name from the C3 column. Right now, if you want to delete C3, you can delete. So It's a good practice. If you think it won't be needed, so you can delete that, right? So now is the bit where we will try to save the data. Now we have worked on the transforming part, then we before that we did the analyzing part. Now let's try to save the data. Oops, it's not data, it should be data. All right, so in order to save the data, we can save in Parquet format. So if I go to Google Parquet format in Apache Spark, so in this functionality, so you can see Parquet is a columnar format that is supported by many other data processing systems. Spark SQL provides support for both reading and writing Parquet files that automatically preserves the schema of original data. When reading Parquet files, all columns are automatically converted to be nullable for compatibility reasons. So this is important. Also, you remember we used the schema, right? Order schema, where we used struct to provide the data types which should be relevant. So if you use Parquet format, so it will keep everything intact. So if like after saving, it will be saved in those data types itself. And this is the Python example, and similarly we have different example for different languages. And if you want to see in SQL, so it will be just select star from table name, and here we are creating a temporary view for this. All right, so now let's get back to our fabric, how to save the data. So to save the transformed data frame in Parquet format, we will add a df.write.mode. So for our df, it is transformed underscore df underscore write. So we will write that in, and this is the mode, and let's overwrite it even if it's there, right? And my format is Parquet, and the location name is files, so it should be in quotes, files, then backslash it transformed underscore data backslash orders 2, and then I'll say print transformed data is saved. If I run this, it gives me some error, data frame dot write dot mode. Oops, so I mistakenly added the dot over here. Press enter. Currently, where how much data we have? We don't have anything in stable, right? In files, if we expand this and refresh this, we have 2019, 2021. These three files are there in orders too, right? So now this transform data is saved, right? Now if I have to create a data frame using this, I can create like something like this. Let's say it is orders.df equal to spark.read.format, and format is Parquet that we created, dot load, and I'll copy this, and in double quotes I'll have this, and I'll say display orders underscore df and press run. So let's see what happens. So it should give me a file. So it is showing me a displayed file, right? So you can see this is my table, and you have year, month, first name, last name, and I think we should have had over here. So if I refresh this, So over here you can see transformed underscore data that we created, and inside that we have orders underscore 2, and we have success folder file, and then this file, like Parkit file, right? So this is what we created here. So if I go back to my original folder, so I have files and transformed. So this is the saved data, which is a transform data, right? Now there is a one more capability of Apache Spark. Using Apache Spark, we can partition the data on the basis of year or a particular location or on the basis of any particular field. So that means if you have a huge data that is in gigabytes and you want to partition on the basis of, let's say, year, rather than just partitioning on 50-50% or 40-40 or whatever, so you can partition on the basis of year, let's say. So let's say you have 1 million records for 2019, 2 million records for 2020, 5 million for 2021, for example. So total you have 8 million records. So you don't want to save 8 million records file, so you can partition by year. So in 2019 file you will have 1 million records, in 2020 you will have 2 million records, 2021 will have 5 million records. So you will have 3 separate files with 3 separate file sizes, right? So how we can partition? So we have the method called partition by. So I'll just do markdown, save the data on the basis of year. So that is partition, and press enter. So once I'm done with this activity, I'll save this notebook and share it with you as well, so you can practice, and if you need to edit or something, you can use that. So now I'll use this existing data frame, that is orders underscore data frame, and I'll write in this and say partition by. So press tab once you are able to see the IntelliSense. So in partition by, you will say year on the basis of year, and on the basis of month, partition the data, and mode is override. Right now this is on the basis of my Parkit files, right? So Parkit, and you can have this again in double quotes, it is files backslash partitioned underscore data, right? So this is what we will create, and then print data saved, for example. So if I press enter, it should give me a new folder by partitioned underscore data name, right? So this data saved. So if I refresh this, one second, I'll refresh the files. Yeah, so under files you will see partitioned underscore data, and you will see year is equal to 2019, right? So currently we just have year 2019, so I can see year is equal to 2019. One more thing, so instead of 2019 I can make it global. So one change I have to make it here. So when I'm doing this order schema, instead of calling 2019, I can just make it asterisk. And now if I run this, it will run for all the files in this folder, right? And if I display this, it will display all the years. And now I can work on, like, if I run this, it will all be for 3 years, 19, 20, 21, right? And now I want to have this transform data, so I can skip that. Now let's save this as well, and save this partition by. So once this is saved, I'll refresh my files. And you will see the partition has happened for year 2019, 2020, 2021, and for 2021 all the months are there. For 2020 it is partition further for month 1, 2, 3 until 12. So you can see this is so useful. I can go to any particular month. I don't need to filter again and again. For example, let's say I want to work on year 2020 and month 5. So I can just go to 2020 month 5 and I can play around with this data. And the best part, you are not duplicating any data. For example, this data Lakehouse is in module 3. But for example, if I am in module 2 workspace, right, and I click on new item, and let's say I click on new notebook, right, and if I want to connect with the Lakehouse which is existing in module 3, I can select this and press on add. So rather than just duplicating, I can work on that Lakehouse and I will have everything, right? So I have partition data, I play. So anyone who is sitting in any place in the world can play around with this data without duplicating. Also, another method is shortcut that we will be explained in the later videos. So this was it about how you can work on Apache Spark to work on around your data, how to transform, analyze the data, then how to save the data, and finally the partition data. This is very important. I believe this is quite intuitive and quite useful. I mean, everyone, whoever is working on Apache Spark uses this benefit. So yeah, this was it about this particular video. So in next module we will talk about delta tables and how to work around on them in Microsoft Fabric. So it will all be practical. If you're following this playlist, I can show that like DP600 certification will be very easy for you. So thanks a lot guys for watching this video. I hope it was useful. Thanks.